Hey guys, we're going to solve an interval problem given a function, and I'm just going to get straight into it. So don't let this problem scare you. The first thing I like to do is I sort of just like to look at the function without any transformations. So without this plus 1 and without this minus 7, I'm looking at an absolute value of x, right? So the first thing that comes to my mind is the graph of an absolute value. And the graph of an absolute value, as we know, sort of has the V shape. I don't know if you've seen an absolute value, probably have, but this is sort of like the idea, right? Let's say I have the square root of x. It's going to come out, I'm trying to write this like faster. It's in this general form, right? So what you have to know is that it's not going to look exactly like this because it's been transformed, right? There are things that have shifted the graph. So what we have to do is focus on the graph. So the first step into finding out the answer to these questions is to find how the transformations have affected the graph. So I'm going to start with the plus 1. Plus 1 inside of this function means a horizontal transformation, which means either to the left or to the right. And it's sort of the inverse when doing these problems. So plus 1 actually means this x plus 1 actually means you're moving to the left. A lot of people think it's to the right because we usually assign right with positive. So what I do after I get this first part of the transformation is I graph it. So I'm going to do my graph once again. Here's my absolute value. And then in order to graph this, I know that I have to go to the left one, right? So here's -1. And now, -1, and then I place my absolute value graph right here. So this is what the function looks like without the -7. This is if f of x just equaled the absolute value of x plus 1. Now, and the reason it's -1 is because we're moving to the left. Okay, now the next part is I need to assess the -7 right here, right? So b x plus 1 minus 7. And outside of the function, this little part right here is telling me that this is a vertical transformation, which means it's either moving up or down. And luckily, outside, these vertical transformations mean exactly what the sign says. So this is going to move down 7 units. Now, in order to graph this, I'm going to once again draw the function of an absolute value. I'm going to have it, instead of starting at the origin, we're going to place it at this -1, and I'm going to have a -7, let's say, down here. Now, in order to plot this, I'm going to stay at the -1, but I'm going to go all the way down to -7, and I'm going to draw the line representing it. And this is what, like, it should cross through the origin, but this is not drawn to scale, by the way. And this is what the general function of an absolute value with this should look like. So now you're probably asking, okay, but how do we answer this question? Okay, I'm going to move these to help you guys out. So in order to answer these questions given, you have to assess the function, which is why it's important to actually have the graph in front of you, which is what I'm going to do right here. So let's start. So here we have the graph for this function. This should be a -7. Okay, now, in order to figure out when it's decreasing, that means when the slope is going down, the slope is negative, the slope is decreasing. So I can see that from this point down, it decreases, right? Which means that the function is decreasing from here. And if I assess the graph from further on, it's not decreasing anymore. It's actually only increasing from there. So the function is decreasing from right here, which is the most far you could go in a domain it's left, which is -infinity. So the function is decreasing from -infinity all the way to -1. And you look, when you're assessing how it's decreasing, you're not looking here, you're looking here, which is why you put -1 instead of -7. So next we have to assess when the function is increasing. The function is increasing from here to here, right? So from -1 all the way up, the function is increasing, which means that it's increasing from -1, sorry, let me put that in red, from -1 to infinity, because there's nothing here that shows that the graph is going to like that or like that or like that, so it's not. And the last problem, which asks when it's constant, trick is it's not constant. Constant would mean we have horizontal slope, but we don't. There's nothing constant about this graph. It decreases and increases. If it were to go like this area, this slope would be constant, but there's no constant. So the interval are right here, and that is how you solve this problem.